Good morning, mathematicians. Today we are going to be looking at our graphs of cosine and sine. So the two trig functions that we have been focusing in on. We're going to learn how they look. We're going to learn it remotely, so I know it's going to be a little different. You probably heard the words I said, graph the trig functions, and panicked a little bit, but we will get through. So if you look at our do now here, I ask you guys to consider two functions. F of x equals sine x and g of x equals cosine x, where x is an angle in radians, so I tell you it's in radians, and by using the unit circle, I'm asking you to fill out the table of values below. So I copied it over here on my whiteboard. I have my two functions, cosine and sine, and I'm going to go ahead and fill them out. So first thing, I told you guys that it is in radians. So I want to convert these angles over here from radian measure into degrees, In case you forgot, we can look at all of this and know that it's in radians here because I have the pi symbol underneath each of those terms there. So that is telling me that this is in radians. Remember, in order to convert them into degrees, we know how to do that. So I'm just going to take my first x value, which is negative 2 pi. And to convert it into degrees, I multiply it by 180 over pi. Again, you can make this into a ratio by putting it underneath 1 here. And the whole purpose is so that your pi's cancel out with each other completely. And then I'm just multiplying straight across. Negative 2 times 180, well, that's going to give me negative 360. So negative 2 pi, that's the same thing as negative 360 degrees there. That's what we just discovered. So I can go ahead and look at negative 3 pi divided by 2. And if I multiply that by 180 over pi, again, the same exact process. So my pi's here are going to cancel out. I'm going to multiply negative 3 times 180 and then divide it by 2. You're going to see we're going to get negative 270 degrees. So negative 3 pi over 2, well, that's the same thing as negative 270 degrees. So you guys can go ahead and convert all of these measures into degrees, or I can go ahead and do it already for you. So I know that negative pi is going to be negative 180, negative pi over 2, that's equal to negative 90 degrees. 0 is going to stay the same. Now I have the same pattern but repeating, so I know that pi over 2, well, that's just positive 90 degrees. Pi, that's positive 180 degrees. 3 pi over 2, that's 270 degrees, and 360 degrees. Okay, so I have my table of values here. And now I'm asking you for your solutions. So cosine, well, recall here, cosine, that's talking about your x values on the graph. So if I'm looking at negative 360 degrees, I want to know the x value there. Well, you can look at your unit circle, you can do the math, but I know that it's going to give me 1. Okay, my x value at negative 270 degrees, that's going to give me 0. At negative 180 degrees, that's going to give me negative 1. At negative 90 degrees, that's going to give me 0. Okay, so that's my table of values here. Continuing the pattern through, and I'm going to have at 0, 1, pi over 2, 0, negative 1, 0, and 1. Like I said, you guys can go ahead and use your unit circle. You can use your understanding and your logic, like whatever way works best for you. Now I'm looking at sine, and recall, I know that sine, that means my y values of my graph. Sorry for the weak marker. So if I'm looking for my y values on my graph, well, at negative 360 degrees, I'm looking at that ordered pair, my y value is 0. At negative 270, my y value is 1. 0, negative 1, 0, pi over 2, 90 degrees, that's going to give me 1, 0, negative 1, 0. Okay, so now you have your table of values here. And then at this point, if I was to ask you guys, we have this all completed. Well, I wanted to go ahead and graph them. on this grid below. Obviously, we are now remotely, and if you're able to print this out, beautiful. Please go ahead and you can start plotting, okay? At negative 2 pi, we went up to 1. At negative 3 pi over 2, we're at 0. At negative pi, we're at negative 1. Okay? If that's not the case, you don't have this able to be printed out, I want you guys to go to decimals, just like I did over here. Okay? When you go to decimals, I'm going to show you from the start. We're going to leave this site. You're going to hit start graphing. Okay? You're going to hit this wrench in the corner that's graph settings, and you're going to change your x-axis here to what my smallest x value is, which is negative 2 pi, all the way to my highest x value, which is 2 pi. And my table of values also told me that here. So I'm just going to delete this negative 10. I'm going to write negative 2. And we're going to get, I don't know, what happened to my pi? Oh, if you hit this, sorry, I'm experimenting as well. If you hit this, the keyboard comes up. So I'm going to type in negative 2, and then the pi symbol is down here. So my grid changed there. I'm going to make my x max to 2, and then my pi symbol right here. Okay, so notice your scale here changed. However, this also is not in, like I don't see my radians down here. I see 2, I see 4, I see 6. So also what you want to do, you want to add here where it says step, click that, and you're going to add pi. And notice your grid completely changes and it matches our paper right here. Negative 2 pi all the way to 2 pi. Negative 2 pi all the way to 2 pi, which is perfect. So I'm going to go ahead and type in my function, just as if this was my graphing calculator. I'm going to type in cosine, parenthesis x. And that's my grid right there. I'm going to hit this plus symbol, and I'm going to do a new expression and type in sine of x. Okay, so I have both my functions in here. I have them both graphed. If we look at my pattern here, in blue is cosine. So at 0, it went up to 1. At pi over 2, it's at 0. At pi, it's at negative 1. At 3 pi over 2, it's at 0. That's the exact pattern that we're seeing on our table here. And then at sine, we were at 0, 0, we were at the origin. Our table said we're at the origin. Then it goes up at pi over 2 to 1. Then it goes to 0, so on and so forth. So you guys are probably thinking in your head like, oh, this has a pattern here. We can see that by looking at my table of values. Okay, it's cycling, or it's oscillating, which is what we use in our trig unit. So it's oscillating up and down. It has that pattern. Okay, so now I want to know what the domain and range of sine and cosine are, and we want to state them in interval notation. So the domain should be very simple for you guys. Why am I saying that it should be very simple? Well, Danny, I'm saying that it's going to be very simple because as you are thinking, they provided me with, I'm trying to pull up, they provided me with what I needed my domain to be. They gave me a table of values here, negative 2 pi to 2 pi here. However, I know that if that wasn't the case, my graph is going to keep on isolating up and down, up and down, up and down. Okay, we just changed the domain. So my range, I want to know, remember range, if I'm thinking of range here, my range, Brianna, is talking about my lowest y value to my highest y value. So thinking of my range here, Max, you might see that your lowest y value according to your table is negative 1 for both of your functions. And your highest y value, according to your tables there, is positive 1. So that's telling you what your range is, negative 1 to 1. And remember the direction said in interval notation, so both of these should have brackets included because negative 1 and 1 are actually points on my graph. my domain, or my x values, I know we discussed it, but we didn't actually write it. My domain here, Brianna, is going to be negative